we'll say about only the graphs. Till graphs we'll discuss. The properties only the remain thing. In week 6, nothing more. Only the properties and solving some exponential equations that we'll do in the next session. Solving some we'll do till in this session. Properties and related applications we'll see in the.
Sir, can we ask doubts in week 6, sir?
Yes, that's why this session is for week 5 and 6. I don't know what is the name in the calendar, but this session is for week 5 and 6 both.
There is one doubt that I have in activity 6.5, sir.
6.5, okay. Just a minute, let me present my screen. Hope my screen is visible to all of you. Okay.
Question
6 point?
number 1. 6.5, sir. 0.5. Question number 1.
How many digits are there in 15 to the power 7x square? So how we can find this? Anyone have idea? Can tell using the logarithmic. So we will use the log function here. How we can do this?
I couldn't find, I could not think of a solution.
So anyone have idea how to find this?
I thought of splitting 10 and 5, so 10 power 7x and 5 power 7x, like that and all I was thinking, but then I wanted clarity. Yeah, sorry, 10 power 47 and 5 power 47, like that I was thinking. So 10 power 47, 49, sorry, 10 power 49 will have 50 digits, but 5 power 49, I don't know how many digits were there. So I thought of splitting the bases as 10 into 5, but that is not the right.
Actually, there is a no. If you see that if it is a think about if you think that if it is a suppose this is a I'm just taking the log with base 10, okay, and if you think this is log here, so if it is see that how many digits are there, this is 2 digits, right?
Yes, sir.
And if you take of log, it will be 1.
Okay.
Right?
Yes, sir.
And again, if you think like till 99, if you think with the log base 10, what it will be? It will be lesser than 10, right? Always it will be, no, not lesser than. It will be lesser than 2. Because
Yes.
log 10 to 100 will be 2 exactly. Correct?
Yes, sir.
So are you guessing that if it is suppose this is, so now till this is 3 digit, no?
Yes, sir.
And once it is become it is 2 digit. Once it will become 3 digit, it will be value is 2. Correct? Once
Correct.
it is 3 digit, and till 99 199 it will be the same. It will always less than or equal to 2.
Yes,
Right? Once it will be 4 digit, the value become 3.
Okay.
So is there any pattern you are saying? Looking that okay, how it is
Yes,
there?
10 cube, 10 cube, 10 square. That.
So this pattern because of this one. So suppose this is 49, okay, and if you take log, okay, log of, so this tells you digit. No, this is something telling you the digit that if it is 4 digit, then value is less than or equal to 3. If it is 5 digit, then value is less than or equal to 4. If it is 5 digit with base 10, then value is going to be less than or equal to 4.
Yes.
Correct?
Yes, sir.
The same way can we think here? The same way can we think here also?
Like log 40, log to the base 15, sir.
So if it is log 10, 15 to the power 49 is there.
Okay.
So this could be sent as here in the multiplication,
Yes.
and this is log 10, 15. So what it's give? So see that whatever you are log taking, this gives you the number of digits and some value. So this integer value gives the number of digit, right? It is if 3 then 2, then total number of digit is going to be n plus 1. Like it is 3,
Okay.
then you are getting value 2. If you are getting value 2, then I just add 1.
Okay. Okay, sir.
This pattern we need to follow the same. Here
Okay.
you see this value is going to be some 1 point something. I have to use the calculator here.
Okay, sir.
And 49 into multiplication of something, that whatever the integer value will get plus add 1.
Okay, sir. Okay, thank you, sir. Thank
So this is the pattern there. Okay, this is the log property. So let's discuss the log.
Sir,
uh,
sir, why we need to add one? Can you repeat? I did not get it, please. Thank you.
sorry, which one? Where?
See, in the solution, you said 49 into log 15 to the base 10. You said one integer value will be coming and you need to add one, you said. I did
uh,
not get that.
so 1 is here because of this one. No? If it is 10 here, say your log value are getting 1, right? So
Okay,
how many digits are there? We have digit 2, but here we are getting 1. So that means I have to add 1 here. This pattern follows for 100 also. If 3 digit is there, then value
okay,
is 2 you are getting. And if it is till 199, where is that 199? Till 199, the value is going to be 2 point something. So just take integer part and add 1. That is going to be the number of digit for that number, right?
okay, okay,
That's why the same pattern will follow. Whatever the log value will get of the whole number,
okay,
and take the integer part after multiplication, take the integer part and add 1.
okay, that's fine.
That is going to be the number of digit.
Okay, got it, sir.
Okay, so let's talk about the logarithmic function. So before the logarithmic, why the log? So the log is actually purposely created. It is not by random. Like we know the polynomial, suddenly came the polynomial. Even the trigonometric also, it came by by the nature, you can say. But log is actually created. It is not directly came like okay, suddenly you got that. It is the created because of the inverse, like each function. See, whatever the function in the it will exist in the nature, it surely some it could be one or not. So exponential is, we have seen that it is increasing, then it is one we can say. There are two things is there. One, just a minute. Okay. There are two things is there. If a function is increasing, okay, some interval, like let's say some interval a to b, then in that interval, it is one. Okay. If the function is increasing in some interval, if it is in the for whole real line, in place of it is whole real line, then for whole real line it is going to be 1. So exponential have this property. Exponential is strictly increasing. It is strictly increasing, that a power x. A power x is strictly increasing. So it is 1. And whenever it is 1, no? Whenever it is 1, what it means that suppose you have this function, okay? You have this function, let's say this is 1, this is a, b, c, d, and these are you are getting. So for this one, you got suppose this one, let's say 1, 2, 3, 4, 5, you have to divide. This is you got this one, you got this one, this 4, you got this 4, and 5 is forget about the 5, okay, or let me erase it, okay. So this function is 1. So 1 means if it is 1, no. So can we think that, see, this is domain, and this is codomain. So function is a machine, no? Function is a machine that it is you are giving something and it is giving some output. So can we think of machine which we can think this set as a domain and this thing as the codomain, and whatever the output you are getting, the same if you apply on the same here machine, whatever the machine, that it is back to this it is giving to be the this one back to the that is called pre-image, giving the pre-image. See, even here is not necessary for onto, right? I'm not asking for onto. At least, see, in some interval it is 1 1. Okay, in some interval, if it is 1 1, in that interval we can make onto. Correct? Is that word is correct? If it is in the interval, it is 1 1. So we can bound our range, right? In that range, we can bound and say that it is 1 1 and onto. Is the word is correct? And say that, okay, if it is the function is 1 1 and onto, then it is inversible. Because of that, it's enough to say that if it is 1 1, then in that where the function is 1 1, we always get the pre-image, and it means one pre-image, not. And if it is one unique pre-image, then we can think about the the function definition also. One input you are getting unique output. If it is not 1 1, suppose it is not 1 1, here is also one, that for this you are getting some different a prime. So once you are inverting, you are getting two. Once you are inverting one, you are getting two different output here. Once you are getting the inverse. So for such case, you cannot think of function. Like this is the definition of function. If you are giving some input, you are getting two different output. For this one, you cannot think of function. So for that, you are not going to. So function is not 1 1. So you will say no. The inverse is not exist. Inverse is also a function. Correct? Getting to all of you why the inverse thing, why the concept of inverse function is came here. It is not by by nature it came. It is actually constructed. It is actually constructed. The inverse thing. Is this what I'm saying? Is this clear or fastly I speak? Please, anyone?
No, sir. Sir, understood, sir. Sir, but
Yes, sir. Yes,
like this, for the for only one function, there is the inverse function is possible.
Yes, yes.
Yeah,
Why
yes.
I'm saying why the reason also, not only
Yeah,
set
reason
the one.
understood, sir.
I
Reason is
said the reason also why it is so.
in that
So actually,
particular
this inverse thing
interval
is
only we can think of that.
yeah. The inverse thing is not by the nature, by the existence of the mathematics and the nature. It is not by. It is actually constructed, and the same thing is there. So this is the inverse. This is the inverse meaning is that, and if it is 1 1, then we can think the inverse. So the existence of the inverse function is because of the 1 1 is enough to say, because we can bound our interval and say it in this interval it is 1 1 and not 2. That's why, as usual in the time, like when we in the 10th standard, we used to study, if it is 1 1 and not 2, then function is inversible. We 10th standard or even 12th standard we used to say. But here is enough to say 1 1. The reason is we can bound and talk about the inverse.
Yes, sir.
So this is one part. Then so exponential is actually increasing, and if it is increasing, then directly it is 1 1 we can say. And this is also easily you can prove. No, this is it is actually 1 1. If it is 1 1, then not necessarily it is increasing, but if it is increasing, then it is 1 1. The reverse part not true, but this part is true. Okay, and we can prove easily. I will suggest you try to prove. This is very very easy proof. I'm just leaving this one, this part. You can try yourself. We use the definition of 1 1 to prove it. Use the definition that increasing information we have, and we have to prove 1 1. So try to use the definition of 1 1 to prove the 1 1 function. The function is 1 1. Okay. Now, as the exponential is increasing, as we have two things that last time we studied about, if it is 0 to 1, then graph would be like this. And if it is a belongs to 1 to infinity, then graph would be like this. Okay. So here both will intersect at here at 1. Okay. So this is for greater than 1, this is for less than 1. Okay. So now we know that the function is inversible. So we will exactly construct that. How we can construct? So we know the one thing we have to be concerned about that. If we have a graph, okay, and we are talking about suppose this is a function we have. So inverse, actually the property of inverse function is that it is, so no, so the thing is like, that symmetric thing, no, you have studied about the parabola, that how it is symmetric, that whatever this distance is here, the same distance is going to be with correspond to this one. If you get this is the symmetry, meaning that like whatever you are getting here, the same distance is here also with respect to this line. This is the meaning of symmetry. So inverse function is symmetric about the line, this one. Suppose this is the graph if you have here. Okay, this is the graph if you have. So what is going to be the inverse? How we will draw this graph, inverse of this function? So with the symmetry, we'll try to draw. With
Sir,
symmetry,
take the mirror image.
mirror image of with respect to the line y is equal to
Y is equal to x.
something we did. Y is equal to x. So see that how it could be. See, the first thing we have to note here that this is, this is lying in the positive side of this, in this portion it is lying positive side of the y-axis. Okay, so if positive side it is lying, then inverse will, in which side it will lie?
Negative, sir.
Hmm?
It has to be in the opposite, negative, sir.
So no, so it is lying in the positive side, no, of y-axis, and it says we have the symmetricity with respect to this line. So if it is lying the positive side, so then where this line should lie? It is, will the negative side of y-axis, or negative side of x-axis, or negative positive side of x-axis?
Negative side of y-axis, sir.
No, how it is? How? No. That's the thing here. Symmetry. Think about the symmetry of y. So that's why I'm saying symmetry with respect to the line y is equal to x. If it is lying in the positive side of y-axis, so it will lie in the positive side of, sorry, if it is lying in the positive side of y-axis, so it will lie, the inverse will lie positive side of x-axis, because this is happening. So that means this side will lie this side. This is the mean of symmetry. Okay. And now how the graph, now something we thought about. So see this, now think about, as this line is a kind of asymptote is happening, where it is positive side and increasing form. So which line we know that it is going to be symmetry. So either by, so surely that y-axis is going to be a symmetry here, because that line, because of the only thinking about this line. See, this is symmetry, symmetry with respect to this line. So this has become a asymptote. The x-axis will become an asymptote. So inverse have y become the asymptote. So there are two ways. Either it could be like this, or it could be like this, right? There are two only ways to be a symmetric. But this could be ever, this one will ever, or this one.
So the second one will.
Yes, upper.
Sir, the
Why it is
increasing
so?
one.
Why it is so?
Because positive x is, in the first part we have seen, it is asymptote is a positive x-axis. Inverse it will be in the positive y-axis.
Okay, positive y-axis. That's the one thing. So the reason is, so let me erase it and let's think about this one here. So what is happening? So let's see it here. Let's try to visualize the symmetricity. I took the tougher one because of I took this one. A belongs to 0 to 1. Here the symmetry will to see it will be difficult. Okay, but let's see the symmetricity is happening. This is the y-x 2x line. So this all will intersect at a single point. Okay, and see that this is as it is increasing. As it is increasing, the symmetry is going to be very that not symmetry, that line, that curve is actually very close to x-axis. Okay, this is something using that we can think, or so here as this, if it is negative value, if it is negative value is going, it is if it is negative value, the function is most rapidly it is increasing, and if it is positive value is going, it is very fast to going to 0. It is going to be 0. The same way can we think about the symmetry. Now by this way, let's talk about it is symmetry with respect to y. So here can we back to here on this. So it says that if it is even x is in the for this function, it is going to be 0 as x is increasing. Okay, as x is increasing, this function is goes to 0. And what about the inverse then? What about the inverse? As c, it is going to be 0 when x is increasing. So if it is going to 0, then which one will increase?
1.
1. Sorry, with respect to y will increase.
Yes.
Correct? Because this is the symmetry meaning. If it is very close to see, as x is increasing, it is coming to 0 y. The then how inverse will go? As x goes to 0, or you are coming too close to 0, y will increase. So that's the here. And also think about with the symmetry that distances also, if you think about the distance, like with respect to this line, this is the distance. Okay, this is the distance. So how we will keep the same with the same distance, right? This is going to be the similar. It is not exactly, but it is going to be. This is the maintaining distance. And in this side, see that the maintaining distance. Going far away, so this is going away. If you are getting with respect to this is away, with respect to this, you will get away. If it is away, then it is away. This is the symmetry happening. Is that, are you all of you are able to visualize it?
Yes, sir.
So this is the symmetry.
Yes,
So
sir.
it is the complex here if it is less than 1, okay? But it is very easy when a is greater than 1. A is belongs to 1 to infinity. So in this case, the exponential is our this one, and this is the line. Now the same everything will follow. It is if it is the positive side is lying, then this will also positive side of x-axis it will lie. So it will be go like this. Now the symmetricity, see that everywhere you will see the same symmetry. This distance, this distance. This is the inverse thing, and this is our. So they see the how the symmetry is happening. This is the symmetry happening with respect to line y is equal to x. It will be easier to visualize in the greater than 1, but it is when it is a is less than 1, in that case it is a tough, not tough, it is visualizing thing. So this is why I am saying if you are forgetting about the inverse definition, inverse, how the graph of the inverse would be, if it is a complex, if you don't know even if you have a graph and ask about the inverse of the graph, then and a very complex, very complex expression is there, then symmetry, with respect to symmetry, we can think like, suppose somebody says that, okay, uh, this is the graph of a function. Okay, somebody says this is a graph of function and ask about the inverse. So actually this is not even 1 1. Okay, this is not 1 1. So it's like this. Oh, this is also not 1 1. If it is 1 1 case, no, so it surely it will be, if it is lying in this part, then it will be always lie in the positive part. Or if it is like this, even you can think the inverse of x cube. So graph of x cube is this one. X cube is this one. Right? This is going to be, this is x cube. And draw the line here. Okay, y is equal to x. And now we need to think about the graphs of inverses. I don't know what is the inverse, but if we, without knowing to be the inverse, can we draw the graph of the inverse? We can, right? If this is symmetry, till here you can think, if this side is going, so that means inverse will go this side, like this. Then symmetry will happen, right? Is that correct?
Okay, sir.
And if it is going to by
Yes,
this
sir.
side, that means this will go this side. Then symmetry will happen. This is the meaning. So that's why if you remove that these two, then inverse will be like this, which is, if you check that, this is, which is x is equal to 1 by 3.
I have a doubt.
Mm-hmm.
Week 6 activity 6.7, sir, in that.
So 6.1.
6.7, sir.
6.7. So okay. So
Second
let me
question.
finish this one. Let me finish then this one. Then we'll discuss that.
Okay, sir.
It will not take much time now. I will almost to finish also regarding the graph. So this is the way. So first think about the graph and then inverse. Then by this way, if it is a power x is, as we know, 1 1, then inversible now. If it is 1 1, then inversible now. So how we can construct? So exactly the inverse input is we are getting and getting output. So how we can construct? So that construction, this log is actually logarithmic, and it is says that if you give this expression is like this with respect to this. So the base is there. So the way this is base and this is power. So same way this is base. And whatever the output you are giving, give that output here. Okay, whatever the final output is there, you just give that output, you will get the value of x. So suppose you got here a power x is equal to b, where suppose x value you take alpha, okay, then a power alpha is equal to b, then exactly the reverse. That's why it is 1 1. This is, if you see that this arrow is the both side, because the on whole real line it is exactly the inverse thing. Logarithmic can be interchanged with the exponential. And how it is so? So this is like this. So just base is the base, same is written to be here. You are getting alpha when you are substituting x is equal to alpha, you are getting b. So give here b, you will get alpha. That's the inverse thing. That's why, so finally a power x, if it is you have function log, so exponential function, then logarithmic will be a power a by base a to the x. Okay, this is the relation exactly. And this arrow is, I am giving the emphasis here that it is exactly true for all real number. That's why it is both side is actually, the reason is it is constructed, actually log is actually constructed, say that this is a notation, this is a just a notation of log. This term is still here is notation. This term is still notation, like as you say to fx, where f is just a notation, no? So here this log base is just a notation that you are taking the log with base a, and this is your x. This is your x here, as this is your x, and you are giving to that notation to this output value and giving the input, getting the input value. This is actually constructed. Okay, so this is one thing. So log. Now let's talk about the graph of the logarithmic. So as here in previously in the exponential form, when a is greater than or less than 1, in that case the exponential goes like this. Now we got the inverse thing. So the inverse thing, so it is going to be log with base a is again will follow in this interval, it is lying with the same. And in that case inverse is going to be this one. And if it is a is belongs to 1 to infinite, then graph is like this for the exponential. So logarithmic graph will be like this. Okay. And this is something. Okay, this is one. Anything more is here? Solving exponential equation. Properties is there. Okay, I think I'm missing anything. Okay, I want to tell you. Okay, let's talk about something more. So we can talk about properties also. That properties are, let me list out the properties. Even you can just Google that and you can get the properties easily. So if you just Google that, so it will be easier to get a log formulas. It will show a table, and this all lectures. So let me list out here itself. So log of, if you have two, so everything. So here is, I don't know, many people just casually write the formulas here, like if you have two number m and n, if you are in the multiplication form, then log value will be added here separately after taking the log values and add them. But everything here with base any a is anything, okay, with the in this domain. So a is actually lying 0 to 1 union 1 to infinite. The same rule will follow here. And here is a domain is remain. No, one thing is that's why the here this came, this is generating that domain of log. So here what is going to be the domain of logarithmic? As the logarithmic function is constructed, but purposely for the getting the inverse of exponential. So what is going to be the domain of log?
0 to infinity.
0 to infinite. The reason is you are getting always the positive values of the exponential value is always positive. So that means you will give the input, because log is inverse, just inverse. So you will give the input here for the log is as always positive. Always you will get the positive value. So log will behave. So see that this is, that's why it is, I also said that it is lie the positive side of x-axis also. And that's the symmetry thing. The symmetry tells, and using that you can itself tell that okay, the logarithmic domain is going to be 0 to infinity. No need to remember, even you can just think and use the some basic property and think, you can think even the whole thing about the log. Okay, so this why I am saying this, the domain of log is positive, then this m and n should positive. Everything will follow in its domain. If this rule, even the whole rule of the log will follow on its domain. Okay, nothing more. If it is we are changing in negative side or one or anything, in that case, rule may misbehave. But if it is in the domain of the log, means positive a should be in this here. If it is in that range, in that domain, then in that case, the rule will be properly followed by the log. So this is one part. This is one rule. The another rule is if you are dividing that any basis now, this is going to be subtraction. and everything can be proved easily. How we can prove? I think this is correct. Yes, I think yes.
Yes, sir.
This is
Yes, sir.
easily can prove. If you want to prove how it is so just assume this log m by n is x or even alpha. Let's assume this is alpha. Okay. Now this can be changed as exactly in, suppose this is this form. So this a power alpha is going to be m power n. Sorry, m by n. Sorry, m by n. This is going to be m by n. So then what we can do now? How we can prove it here? Sorry. Anyone? This alpha value should equal to, right, this one. This alpha value should equal to this one.
Both the sides.
Can take log both sides.
If you will take log both side here, so this is going to be alpha log a. So we'll get the same, no? M by n. How we can prove this?
The log A is 1 now.
So we can first multiply and that side and then
You can multiply.
first and a to the power n by
Mm-hmm.
then we can take that.
Oh, so by this way we can do also. That's, I think, correct. If we use this formula, then we can prove
Yes.
only whatever we know. So we can multiply here. This is n time al to the power alpha. This is m. Now if we take log here, so log will be separated.
Yes.
So before that, if you know this formula, then we have to prove this. Okay, let's do the proof for this one. This is we have. So how we can prove?
ब्रश केला का तू
Please do
ब्रश
unmute
केला
yourself.
का ते प्यायचंय तुला
Okay. So how we can prove it here? This one, log m plus log n. So again, the same way, let's assume this is a mn is going to be alpha. So we got here finally, this is going to be alpha is equal to log, this is log will come here, log m minus, you will send this to this side. So, but we have to find this one, no? This is a to the power alpha is equal to mn. So how we can get now, how we can get this one?
What? I don't understand, sir. So we are getting now, sir, already alpha is equal to log m minus log n. So that will be equal to log of m by n.
This is we proved using this one, we got this. But I want to prove this one. So how we can prove this?
Okay. Oh, hold on. Okay, sir. So, okay. I'm-
How we can?
We can take m to be some exponential function and n to be another exponential function.
Okay.
And then when we take the logarithm of each of them, then the log and the exponent, say for example, if it is m equal to
Okay,
m
so let's take here. So this is a base m is let's say t. Then a power t is equal to m we got, correct?
Yes, sir. Yeah.
And similarly, if we take log a power n is equal to s, then we'll get here a power s is equal to
N.
base a to logarithmic base a n is we'll get here n. Now if you multiply here, so if you multiply here, then it is going to be
A to the power alpha is equal to A to
m. No. So here if you multiply these two, if you multiply, like if you think about a power t into a power s, this is equal to a power t plus s, right? And this is what? This is our m into n. So m into n is equal to a power t plus s we got, correct?
Yes.
Now if you take the log now, log mn, this is log with base a. This will become t plus s with a. And this is log value a is going to be 1 with the property even just saying to be a power 1 is equal to a. And this is going to be 1 and this is going to be t plus s. And our t is log a and s is log n. Sorry, log m and n is log, s is log n. So by this way we can prove. Okay. Similarly, other proof I will just, so let's write the other formulas we have of the log. Log of a or even b to the power k is there. So this could be written as k time log ap. And fourth is log with, here is what are the other formulas? We have log 1. Okay, log 1 is already log the base a1 is going to be 0. And log here is one thing I will from my side, I will base change formula is there, that if it is a and b is there, this could be written as with any base, not even 10, any base you can write it here. Like I'm writing here base 10 is, this could be written as like this, just breaking 2 on base a, sorry, base 10. This is one important thing. Even not even 10, you can take any base here, any base 2, 3, 4, 5, whatever base you want, you can take the base and break it in the. So everything can be proved here. You need to prove also. You can prove this one.
Sir, can we take negative?
No, so everything is falling on the domain of the logarithmic. Okay. Everything is on the domain of. You cannot go. This rule, every rule is under the domain of log. Or what are the conditions for the log? Then you are able to do all every formulas smoothly. Otherwise, it will misbehave. It may not true.
That means greater than 0, not equal to 1.
Even 0 is not included, no? So you cannot do also there for 0.
Okay, sir.
And the next is, this is one important log. It is a to the power k and this is b here. So this could be written 1 by k log. 1 by k log. So previously, if you see that here, a to the power a base a, b to the power k is just multiplied here. See that it is in multiplied ahead. But if this is power of the base, okay, then it is a division thing. See the differences. And everything, I'm just leaving this part, sorry, I'm just leaving this part to prove. This is sixth one. And seventh one is that log AB could be written as base change. Again, here is the one another base change, but this is log BA. Can use this one as B as a base and A as a function value, that output. This all important property. Even if you see the many problems, no, this property will used here in a very comprehensive manner. These are important, very important. Even this one is very important. This is sometimes the base is not same. Many problems are base is not same. So either you can change the whole problem on the same base by dividing by that like this, or you can sometimes it is written as in the power of, and you are unable to guess that. So try to minimize that. If it is suppose this is a kind of 8 to the power 4 is the value is asking, or let's say 16 is there. So everything you can change on the base 2. So this could be written as log 2 to the power 4, and this is 2 to the power 3. And one by one you can do. This is 4 times 2 to the power 3 with 2. And in the next step, 4. And this 3 will go here, and this is log 2, 2. And finally, we got the value 4 by 3. So 8 with base 8, log value 16 is this one. Sometimes you are unable to guess that. So this is easy to think about and change on the minimum where the power can change 3 to the power, 5 to the power, and then do that all using this formula and this formula. These 3, 4, whatever I wrote here, these all are important. This one is also very important. Changing base. Okay, if you know these all are, and if you use this very frequently, no, even not even single exponential problem is going to be even single problem can be solved with these all. Okay. So these are the properties. I don't know rest all properties. We'll check that from the Google if you want. Everything can be proved, and everything will be in the domain. Every formulas we have in the domain only. Okay, and let's talk about now the rest part. I'm just leaving. Okay, rest part is we'll discuss the summary thing is now over. Okay, so let's talk about the one thing that finding the domain, some complex. Like here, suppose I'm giving the base 10, and this is you have, or in let's say base 2 is there, and a very complex Aryan cube. Now let's talk about we had done with the polynomial. So this is 3x square plus 1. So what is the domain of this function? What is going to be the domain? Anyone? How we can get the domain of this? Am I audible?
So that
Yes, sir, you're audible, sir.
expression greater than 0, and then you can.
Yes. So if you want to get the domain, so domain means the first step says that this whole thing should be. So this is a composition. No? This is a composition of polynomial and log. So this whole thing should be greater than 0. So that means this 3x square, sorry, x to the power cube plus 3x square plus 1 should be greater than 0, not even 0, greater than, strictly greater than 0. Okay, now we have on the polynomial. When the polynomial, this polynomial value give the 0, sorry, greater than 0. So let's draw. So let's draw the graph here. First draw the polynomial. That's why one by one step we are learning. We are done with the polynomial. So this graph, how the graph would be. So add what is the int behavior here? This
Sir,
is
it will go down to negative infinity.
this is the int behavior.
Yes, sir.
Now let's talk about the roots. What is going to be? So surely at least, so this is 3 degree 3 polynomial. Surely it have at least one root is sure, that real root. Maybe two roots could be complex. We don't know that. But yeah, one root is fixed because of the sign. Okay, this is one thing. And now turning point, or what are the things are roots, multiplicities. So if you know the roots, so anyhow we have to do the, we have to find the factor, we have to do the factorization, then we are able to guess the root. So to guess the root, we know that, FOIL method, that saying to be take the 1 here, and if you put here -1, then it is going to be -1 plus 3 plus 1. So this is 2. So -1 is not, so you are not getting 0. So -1 is not root. Okay. 0 is not root. 1 is not root. Then what is going to be the root? I don't know even what is the root. But can we get that? Okay. Can we fix the root? Something, how we can get the root here? Anyone? What is going to be the graph of the function?
It's a cubic polynomial.
It is a cubic. So
on the positive, towards positive infinity, the y value will become positive infinity. Towards negative infinity of x-axis, y value will become negative infinity.
yes, we in the behavior we know. Just now I told you we got the in the behavior.
Like, sir, I'm really confused in all, like in the domain part of this logarithmic function, because it is very difficult to find. I've tried there are a lot of questions regarding this only.
Yes, sir.
Okay, x cube plus 3x square should be equal to -1, sir. Then it will become 0, right, sir?
Is -1 means, sorry, x cube?
If the value of x cube plus 3x square is equal to -1, that -1 and +1 will cancel out and we'll get a 0.
No, if it is, sorry, could you repeat please? If it is?
If the value of x cube plus 3x square is equal to -1, then that -1 and we have the +1 in the cubic polynomial towards the third term, sir. So that will cancel out and we'll get a 0 there.
X, okay, you are saying the x cube plus 3x square is negative.
Should be equal to -1.
-1. If it is -1, then this is going to be, no, so this is not the way. This is not the way. So what you can do, see, this part is never be negative. This part will never be negative. This could be negative.
Okay, correct.
So you said this one, but think about this one. This part will never negative. This is square. This could be negative.
Okay,
so if it is 3x square plus 1, and
okay,
we got some.
So we can say x cube should be greater than, no, x cube should be negative of 3x square plus 1.
So this, if you think about this one, only the 3x square. So 3x square don't have any root.
Correct.
And how the graph will be 3x square?
Upward facing parabola.
Upward tracing parabola, yeah. So it will be, and where it will be? At the here.
1. The minimum is 1.
Minimum is 1. Something like that.
So
And x cube, if you try to draw the graph of x cube, see that how it will be. So let's
x is 3x square coefficient 3, no?
Sorry.
So graph this 3x square plus 1 coefficient x square 3, no?
Coefficient is 3x square.
Strictly 3 x-axis, no, draw of this type graph.
So yeah, so let's see that we are actually reaching to the root. We are not getting exact root, but we are actually reaching to a root. So how it is? So say I draw the graph of x cube. Okay. Sorry, 3x square plus 1. Now draw the graph of x cube.
Actually, it will be, this is a y-axis, no?
Which one? This is y-axis.
Yeah.
This is x-axis. So draw the graph x cube. It will be like this, correct?
Yes.
So it is giving the surety that somewhere it will intersect. So we don't know exact that, but yes.
Okay.
Here it is intersecting.
3.
So see that what is happening here. So it have one root or 3 real root. What it is telling?
One root.
Only one real root. It will
Yes.
intersect only one here. So finally what you are getting? So finally you are getting. So let me now. It is very much clear with the she told a very good thing that she was saying about this one. But if you concern about this one, so this is a graph of the parabola, and it will intersect. It is now we are getting the surety that the x cube will intersect this graph, and at here we don't know exactly. And now the rest 2 root, it will be exist or not. We got one root here. Okay, we got one root here. What is the next root? The next root will exist or not? Is there a need to another real root? It will never. The reason is now x cube will never intersect. It will intersect the x this parabola once, and now it will know. It will go this side and it will go above. Never it will be. So that means finally what is that? Whatever you have x cube plus 3x square plus 1. So you have this parabola. So graph of this one we exactly don't know, but we are sure that it is like this. It is coming to here, and it is a x cube is there, no? So like this you can think. Okay, not till here. This is okay. This is going to be the like this. So where I were like the same way here is that. So here is it is intersecting. Only one root is there. Now rest 2 roots are complex. So we are not going to only one real root. That means it will intersect.
Sir, the root, when we are adding these two points along the graph, when we are adding the points along these two graphs, x cube, when it takes a negative value, at that time only we will hit a 0. Because 3 square plus 1 is always positive. So on the positive x-axis, we will not get a 0.
So yeah, okay. So that true. Yeah, that's the thing. So okay. So this side maybe. So so that's okay. So just a minute. So if it is negative side, I think just a minute. So this is one thing is there, and x cube is like this. Okay, if it will give negative, then it will be both positive. X value is positive. Oh, yeah, it will never give the here it will not intersect. So the output is going to be this. This is negative. The output is negative, means negative side. Surely this is we have.
On the positive side of the x-axis, both the parabola and the cubic function together will add up only to become positive, sir.
I think yeah, just one. So one root is clear that it is giving one root, And intersection point is I'm doing some wrongness here. As the y-intercept is 1 here, so it will be here. It is open upward also, positive is there. So how it will hit here, negative side?
Because when we are adding those values, we are not actually, when we are adding these two curves values, we will get the whole curve value, right? Yes, sir. So on the right side, the parabola, that is on the positive x-axis, both the parabola and the cubic functions both have positive y values.
Yeah, that's correct. That's correct. If you are giving the positive value, this is positive, it will never be 0. So here this is not the root, I'm sure. At this side is going to be negative root is there. Yes, negative value, because positive side is x cube is also positive. So somewhere this side is root. Yes. So that's why how it could be.
So here it means the place where 3x square plus 1 is equal to negative. I think we just have to equate 3x square plus 1 equal to x cube. And what is the solution we will get? That would be the answer. No, will be negative of that, sorry. So 3x square plus 1 equal to negative x cube.
I think let's draw. I think I'm missing something. So let's do separately on the Desmas that 3x square. So let's do here.
If you put -3 in that particular equation, we get 1. So there is only difference of 1 there that we are getting. If you put -3 there.
The intersection is here. That is correct. Intersection is here.
The intersection will be in the positive side of the x-axis, sir, but what we are looking for is value 0 when we add these two graphs. So when
that
we plot the whole, if you were to, in the Desmos, if you plot the full thing, x cube plus 3x square plus 1, that will be, the root of that will be on the negative x-axis.
But here we are not getting, okay, I think I...
But sir, graph checking
we have to add these two, sir. X cube plus 3x square.
Yeah, I'm getting that. I'm getting that. Okay, this is we have. Okay, let me erase these two. Okay, this is the graph. -3 will, so we are sure that it have one root, but one root is there. We are sure that, but where is that exactly will lie? We don't know. We are not able to guess that. I think I made a mistake while guessing. Okay, this way is correct. There is no issue that x cube 3x square. So by this, so 3x square and then x cube. So this is 3x square plus 1, and this is x cube is here. So we are saying to be this is equal to 0. So this is always positive and this is negative. Where they will intersect, they intersected here. But so okay, this function value is going to be here. So what is where they are intersecting? This give whatever the values they are giving. Oh, sorry. So here is our. So here is that negative. That means this is 3x square plus 1. This is equal to negative value of x cube. That's
Yes,
the meaning here.
Yes, sir.
I forgot this one. Negative value of this one. So where these two are equal, okay. So see, if you see that, okay. So now it is very much clear. This is my negative value. So where is that you are getting? No, this is. Let me erase this. We see that if you do the negative of this one, it exactly is going to be the root. Here, where is that intersection point? See that. This is the no. This is 3.104. If you give the negative of it, that is going to be the root. Now, if you see it here, if you give the minus of this one, this is going to be the root. See that here. Negative of 3 minus 3, 0.14. I missed that. This one. I missed that. So this is the meaning of. See, whatever here is intersection. Three, whatever. Okay, this side, not this one, this one. This one. This is the intersection point. And so if you do the negative, that is going to be the root for that one. This part I missed that this is going to be. I missed that. If you send this side now, this x cube is whatever the correct value is. So this tells you that whatever this value is there, and if you draw the graph this one, both value if are same, whatever the point, that is going to be the root. So if you draw the x cube, this is going to be this one, and if you draw the minus x cube, this is going to be this one, and that's why it is going to be. So I wrongly I were doing that same and then adding. This is not. If earlier I send that side, then it will be easy to guess that. So where is the point where both value is the same? That is here. By this way we can guess. Is that clear now? And we are unable to exactly get we are unable to get the exact thing that what is the value 3 minus 3.014. But yeah, we know that one root is there and that is going to be negative. Okay, so in that, so now let's do it here. So this is, so if it is below of it, then function value is going to be negative. And if it is above of it, it is going to be positive. So now the graph would be, if we anyhow we guess that, okay, so my wrongness was there, otherwise we easily can guess that, okay, somewhere negative is here and also going to be the root here, this side. So as now let's draw. So this is one property, this one thing you can in mind you can think. So you can think that, see, this is the leading term. So this is the leading term. Once you do more practice, you will see that inside means in between some range. Function will be like this, but when it is become bigger, function exactly behave like this, only exactly x cube. That's why if you see that's the inner behavior also. It will be go like this and this. So inside, maybe that's why the inside inner part, some portion in between, it will behave like that it will help to be having this one. So that's why if you see that the graph is going like this, and then parabola shape is there, and then back to as the x cube is there, graph of x cube. So if it is less than, so let's talk about we are talking about the domain. So if it is minus infinity to minus 3.104 is there, then we are not going to take as a domain, and 3.3 minus 3 open interval should be 3.0104, and 2 till infinity is going to be domain for this logarithmic function, because in that range it is positive. This part is positive in the minus 3.104 comma infinity. So this is the domain. Okay. Okay, anyone have doubt, please let me know. Now I will take it just out and then close the session. So anyone who have doubt, please let me know.
Activity, week 6 activity, first activity.
Sir, actually, started time summary problem.
The starting time.
Yeah.
The symmetry.
Yes.
Okay. Which problem in 6.6?
6.1.
6.1. Okay.
6 point.
Question number?
Third question, sir.
So here is the domain, the domain is came here now. The domain thing. So what is your doubt here?
The domain only, sir. Actually, third choice is correct. I'm getting the answer key, sir. But I'm not able to understand how that is correct.
So till which place you are able to do? Till where?
Actually, when I tried, I'm getting both. That is, I'm getting both the domains as from 10 cube to infinity and 10 power 5 to infinity. That is what I'm getting. But in the answer key, they've given 0 to 10 cube and 10 power 5 to infinity. But when I try, I'm getting for both the functions separately. When I'm trying, I'm getting 10 cube to infinity and 10 power 5 to infinity. But here they're giving 0 to 10 cube. That part I'm not able to.
So if you are 0 to 10 cube and 0 to and then after 0 to 10 cube and then 10 to the power 5. Okay, you are saying this one.
Third option is correct option, they are saying, sir. But I am getting positive from 10 cube to infinity as 1 union of 10 power 5 to infinity. That is what I am getting, sir.
Okay, so let's see that here. So this is the main log, outer log, and below of it, inside that, this log is for the whole, this one. That means this should positive. This should positive means the whole square minus 8 log x plus 15. This is minus here. And this is, see that this is base 10 is here. This is 1. This is 1. This is a kind of, no, this is a quadratic in log base 10. Log base 10x. Right? This is a quadratic. If you assume this is y, then this is y square minus 8y plus 15. Right? If it is y.
Yes.
And this is going to be y minus what? Y minus this 15. If you drop out, this is positive, means 5. You can break
minus
5
5
plus
minus
3.
3.
So this is going to be y minus 3. So that means this one is positive. This is positive. So let's draw it here. So positive thing is we know. So this is 5. This is 3. This is 5. So this is going to be the parabola. Correct?
Oh, like this we have to think. Okay.
If you then it will be clear. No, we have to always think about the positive, no?
Okay. It was my mistake, sir. Traditionally we will do factorization and we'll equate to 0 to find the root. So I took y minus 5 equal to 0 and y minus 3 equal to 0, and then I try to find the value. Okay, that is
No. So we are not finding the root here. We are actually doing the positiveness where it is positive.
Correct.
So where this y is going to be.
Okay.
So in this range here, so this is positive. This is in this area, it is positive. But here is the y value is talking about the positiveness. Okay, so still that is not this y could be negative, right? This could be negative also. This the whole thing we have to also right? This could be true also. But the thing is like this is so y this is equal to 0, or the graph would be like this. Okay.
I understood, sir. Whatever you have done is now I can understand.
So all of you are getting this, or I have to proceed here?
So we got this.
No, sir, understood. Sir, this equation, that is y square minus 8x plus y, while we put this log value, we can directly do it can be greater than 0 also, and we can decide separately y minus 5.
That's the thing here. This is positive now, means this is greater than 0. And when it is positive in this area.
Got it, sir.
Okay. So the fourth question says the same activity.
This is we have.
Yes.
This is the problem. So what is your doubt here again?
I tried to solve it. I am getting I'm getting everything, the whole real number domain as the domain set. But they have given it is only between -1 and +1 closed interval. No, open interval. That is the answer they are giving. But when I tried, I get everything.
Whole real number.
Yes, sir, I'm getting whole real.
Okay. So this is the function we have. So first thing we have to here and here have to apply both, because both are variable. That means x minus 1 upon x plus 1 should lie. The output should lie 0 to 1 union, 1 to infinite. And this x square plus 1 upon x square minus 1 should lie 0 to infinite. This is the condition. These two conditions we have to follow. Correct?
Yes, sir.
So first deal with this one. So if it is in this range, it is there. Okay, so we have x minus 1 upon x plus 1. So this should, it says that only the problem is at 1. Only the problem here is, both are same actually. Both here and here are the same, only in this part 1 is not there, and here 1 is, sorry, in this part 1 is there, but in this part 1 is not there. So anyhow means whatever the output, so what it tells you that? Sorry.
First, we have to, if we were to solve for the base of logarithm, then x cannot be, x will not take negative values. Correct, sir?
Excuse me, sir.
I think sir is busy on a call or something.
Okay.
So sorry, I got a call.
Yes, sir. Sir,
So
first we have to find for the base of logarithm. That is, first we have to check x minus 1 by x plus 1 should always be greater than 0. So that means it cannot go negative. It cannot take negative values. So x cannot take negative values. Correct, sir?
yes.
So that is for the x part.
No. Here is not negative value. Here is the first thing is that from both functions we have to take such value of x so that, or we have to remove that value so that both functions should not give 1. That's the meaning here.
Okay, it should not give 1. Okay.
Because 1 is the here, okay, but 1 is not here. The one, if your x value is, sorry, whatever the output
Mm.
If you are getting one, if you are getting one, he's for because of this one, then there is a problem because of this one.
Oh.
First thing, the positiveness, if you will think about, so this fraction when it will positive.
When x is greater than 1.
No, if it is x is greater than 1, then become greater than 1. Yes. If it is greater than 1, then it will become positive.
Yes, sir.
Okay, so it is positive. We don't, so x is greater than 1, then it is a positive. And when it will be 1 first. So let's solve for 1.
Okay.
So this is 1, it will be x minus 1 equal to x plus 1. Oh.
It can never be.
It will never be 1.
Yes.
It will never be 1. So that means here is one condition that x should greater than 1.
Yes, sir.
From here we got. Now let's talk about here. Here this should positive. This should positive means when it will positive. This is always positive because of this one there is a issue. So this case is positive when x square is greater than 1.
Okay. Yes, yes.
And this is x is greater than plus minus 1 in that case.
Okay.
So the interval is now already decided. So minus infinity to minus 1 will go, and then union 1 to infinite. Both should, because of this one is 1, this satisfied, and this one is because of this is in union. And we will not take 1.
We have to take the intersection of the of these two.
So this give 1 to infinite.
Yes.
And so now take the intersection, you will get. Okay, so we cannot take, so we have to take the intersection. So now this is we have to, this should follow. That means we have to take the intersection. So this is, that's why it is going to be 1 to infinite.
Yes, sir. But the answer they have given it is negative 1 to positive 1.
Negative 1 to positive 1.
That is second choice is what they have given as the correct answer.
Because it is asking there are no function of the form fx.
Oh, yes. No function. So in that range, minus 1 to 1.
Okay. Now okay.
Okay. Anyone else have doubt?
I still have some doubts.
What is the doubt?
And in activity 6.2, sir.
Okay.
Second question. I got one answer correct, sir. I mean, actually, the answer for f of x equal to ln of mod x, it is an increasing function only, right, sir?
Yes.
But no, but the answer key they're not saying it.
No, not necessary. Sorry, it is not necessary. Let's draw it here. So this is, so this log and with this one.
Yes, sir.
So let's draw it, the graph. If you are not able to, let's draw the graph. First draw, we know that this is, this function is in this form. If it is positive, then it is positive. If it is negative, then minus of you will do, right? This is the log mean.
Correct.
If it is negative, then minus of that you will give, and it will become positive now. So let's talk now on our log here. So if it is positive means we having like the same log. If it is greater than 0, x value is greater than 0, it is we having the same log.
Yes,
so graph, how it could be the graph here?
Increasing function.
So increasing, in that case, it will be like this.
Yes.
Right? In the positive side, positive value is going to be the same as the log. In the positive, it is going to be the same. What about the negative? If it is negative, then we will take the negative of it, and again it will be have the same like this.
Okay.
Right? This is going to be, so not this one. So this is like this. And this is correct. This is the way, right?
Okay. Okay, sir. Okay, now I understood. Okay. Please.
Sir, in the same question, why option C is not correct?
The inverse of e power mod x. Inverse of the inverse of f is the inverse of f is e power mod x. So this is, see, the whole thing is r, no? Here is the whole thing except at 0. Except at 0, the function is not there. Otherwise, the domain of this one is the whole r remaining to be 0, right? So this is not
Yes,
one. No, so inverse, talking about the inverse. See, this bound is not there. No, it is horizontal. If you do the horizontal test, where it is not 1. We are getting
Yes,
two
sir.
different. There are same inputs. Same output. So how it could be inversible now? Because inverse is not only this side asking. It is asking the whole, because the whole is R. The domain is whole R, and asking the inverse of this whole R minus 0. And now this is not 1. If you draw horizontal line test. If you do the horizontal line test.
Okay, sir.
Okay. Anyone have the else
Yes,
doubt?
sir, please wait, sir. I still have. In activity 6.5. No, that's not. Sorry, sir. No, sir, no. 6.7. Question number 2, sir. Question number 2, third choice they have given, we can get infinite number of vertical asymptotes, but we will get only one asymptote.
No. Use the definition of greatest integer, no?
But every time we are actually removing the whole part, and we are still left with only the decimal part, right, sir?
So what about that integers then? So think about that integers. You are removing that fraction. But what about exactly when it is 3, 4, 5 at integers? It is going to be 0, right? Each time.
Okay. Oh, for the integers you're saying. Okay.
Sir, please explain the whole question.
Okay. So this is the so we have the function x greatest integer. What is the greatest integer means? If it is 3.5 or 3.72, this value is going to be 3.
3.
And if it is negative, no, if it is minus 3.57, what is going to be the value?
Minus 4.
Minus 4, greatest integer, less than or equal to. Less than this number. So this is going to be minus. In negative side, it will increase 1, and in positive side, it will exactly the integer 1.
Yes.
This is the greatest integer function. Now think about the whole. What is this? So if it is, so 3.57 is there, and integer of same is going to be 3, then this is going to be 0.57, right?
Yes, sir.
This is actually fraction part is giving, no? Fraction after the decimal, after the decimal is always giving, right?
Yes, sir.
After decimal, to the point, it is giving the value. But what about if I'm taking, so if it is this kind of values, 3 point something, 4 point, or 7, any type, n point, some number is there. That's fine. But if it's exactly n, what is in that case? If it exactly 1. So this is n, and this will also the same n minus n become 0. Correct?
Yes, sir.
Yes, sir.
So in that case, always many times you are not exactly, or at each integer you are getting 0, and log is not defined there. So it will behave like asymptote, no? 1, 2, 3, 4. So it will behave like this. So it is going to be correct. By this way it will go like this each time. See the graph. Because that at here you are not able to get the value. At here you are not able to get the value. Integers, you will get 0 here and not able to get the value. So at 0 this is asymptote. At here this is asymptote.
The third question, the same activity, sir.
So try now yourself. Okay, what is your doubt here?
There are two correct answers. The last answer, that is x cube y equal to 1, I got it correctly when I tried to solve it by taking inverse and all that. But the first choice, x equal to 2 and y equal to 1 by 8, that I'm not able to get it by solving the question.
No, not by solving. You will get, but not by solving. No, you got last one.
Yes,
and
I got
this
only
last one. This is satisfying. So that's why it is true.
Okay, sir.
Put and check the option only.
Okay. Because by solving, I got only x cube y equal to 1. Okay, sir. So we just have to substitute and get it. Okay, sir.
This is the particular value is given of x and y.
Okay.
Okay.
That's all, sir. Thank you.
Yeah. Thank you so much for joining. And if anyone have doubt, please let me know. Now, otherwise, I'm going to close session. Almost done. We have, I think, we have discussed something.
Sir, starting time in symmetry.
Sorry.
So activity 6.5, both questions.
Summary, sir, starting time.
Oh, summary is starting. Okay. Both question. This one. This is in starting. I have discussed.
Okay, sir. I will
So
watch
this is the first question. If you start the session, this is the first, and I explained much. I took time and explained this one. In 2 times
Okay,
I
sir,
explained.
I will watch that. The second question.
The second is the suppose certain amount of M is invested, 5% is straight. So this is a compoundly. So compound using the compound thing. No, what is the amount is there? M and 5% rate is there.
Yes.
So M 1 plus use the compound formula. 1 plus the rate, but it is how the yearly or quarterly it is applying. Annual it is there. So annual means the same will go here. Okay, how many? So it is asking the year. So we don't know the time, but it says that the amount will come what? How many time? Where is that? How many time? How long?
Twice a year.
Triple.
Yes,
triple.
sir.
It will come triple. 3M. This is the equation, and you have to solve this. And you solve for t, right? This is 5%. This M will become cancel out, and 1 plus 5 t equal to 3. You have to solve. If you take this is 6, it will become 6. Okay, this is R by 100, no? R by 100, not only exactly R. This is R by 100, means 5 by 100.
Yes, sir.
This is 105 by 100. If you take log now, you just need to solve now using the calculator.
What's that in last line? Thrice a year. I couldn't understand.
Thrice means 3 times, no? Thrice means, that's why 3 times of.
No,
Yes,
sir. In last line, assuming interest is compounded thrice a year.
Oh, okay. Assuming interest is compounded thrice a year. Okay. Oh, here is the, in starting I was searching, and here is the thrice is.
Answer is 22, no?
Sorry?
Answer this question.
I don't know.
Yes.
So I don't know. The
22
thrice
is
a year
answer.
means what? It is actually quarterly it is taking, no? Thrice a year means 3 times it is applying the compound. Compounded
Yes,
thrice a year. In a year, 3 times means quarterly it is. It is not quarterly, it is written properly, but it is thrice written. That means what? Quarterly. 4 plus 4 plus 4. It will become
Sir,
12,
will
right?
it affect the equation?
So finally the equation will become like this. What? 1 plus 5% rate into, in that case, if it is thricely means quarterly it is applying, then how it could be? 4t, right? If you assume after t time, after t year, it will become value 3m. So that means if it is thricely means quarterly, it is taking the compound is becoming what? Thricely, that means it will what? Oh, this is 4 or 3. What is going to be? Anyone? It will be 4 or 3.
It will be 3 times, sir.
It will be 3 times, not 4. I wrongly wrote here. It will be 3 because 3 times. Each year it will become. So here is the way it is like this, no? If it is the formula, if you childhood, if you remember that, if it is says that half yearly, thricely, or quarterly, or like 3 plus 3 plus 3 time, I don't know what is the name is that. In year if it is in year 4 time is there, or it is 3 time. So 12 a month upon how many time it says. Oh, here is the thricely says, no? N by t is there. So t by n is there. So it will 3 come, no? If this thricely says means 4t will come. This is the formula. Yes. This will become 4t. Not 3t. It will become 4t, no? It will be 4t.
I was confused in this part only.
Sir, if it is compounded thrice a year, then 3t only will come, sir.
It is 3 thrice is there, yeah, actually by this
And
way.
denominator of, you will not have just 5 by 100, it will be 5 by 300 because you are going to divide that percentage by 3 times, sir.
By 3 time also. What is that formula exactly? I have not the
Yes,
interest
sir.
formula is that.
Principal open bracket 1 plus rate by 300 close bracket raised to the power of 3 times number of years.
Plus that 5 by sorry, that not 5, that rate by that 3 100.
Yes, sir. Whole raised to the power 3 into the number of years.
3t, and
Yes.
this is 3m.
Correct. Yes, sir.
So if you are, I'm not sure about, okay, if this the formula, we can generate the formula, no issues. How it is, so see, let me tell you that. So it says
Which
price,
formula,
no,
sir?
we can generate this formula. The compound is actually, the formula can be generated here. So if it amount is m, okay, if amount is m is there, and it says the thricely it is, that means thricely means 3 times in a year, 3 times the compounded means after 4 year, after 4 month, 4 month, 4 month. Okay, the rate is here. What is m? So total amount is m, rate is 5%. Yearly it is. So that means if you are assuming rate is r%, so r by 4, that means here 4 time, fourth annually rate is there. So 4r by 4 and time amount and time is after 4 month is there. So this is going to be 100. The simple interest, using the simple interest, no? Simple interest. This is the interest here. So time is in a 4 month we are taking, no, for per 4, sorry, after 4. So this is one here. So this is after 4 month is the interest will be added. After 4 month, interest will be added, right? And rate is per year is there, means 4 time you have to divide it. Okay, this is going to be now m and mr by, so you can write like this, m by 4, and this is 100, the same. So the total amount is going to be m. So m plus m r by 4 upon 100. This is the amount after 4 month, right? This is the amount will be simple amount, then interest. Then this is become m 1 plus r by 4. Yeah, that the formula is actually correct. R by 4. This is the after 4 month it will be. Now next 4 month means after the next 4 month what it be? This is our amount r by 4 100.
Sir, when we are dividing by 4 months, we are actually taking actually when you take when you divide 12 months by 4 months, we are actually dividing the interest by 3 times because 3
here is 3 means thricely you are taking, I wrongly, here is 3, previously I wrote, so here it will be 3. 3 here it will be 3. So this 3.
Yes, sir.
Now this is amount, and then again the rate r by 3, and then again into 1 upon 100. This is the interest. So the amount will be m 1 plus r by 300 plus this interest m 1 plus r by 3 to r by 3 upon 100. Now if you take common here, what? M 1 plus r by 300. If you take common, this you will get 1 plus again r by 300. So this is the compound. No, what is compound? Whatever you will get interest, it will be added and then interest will apply. So yeah, whatever you said, that formula is actually we are getting the correct. So here is m time 1 plus r by 300 into what? Square. Now thrice it is again after it. Now 8 month is done. Now last is it will come. So 1 plus r by 300 cube. Now per year this 3. So how many year I am saying? How many year? I am assuming t time. So that means here is into 3. That formula is actually what she said is correct. By this way we can generate the formula. Whatever the simple, the definition itself we give the formula one by one if you are not getting the formula.
Okay, sir. Thank you.
Generating formula, is that clear? How we will generate that? How the compound is
How to generate process?
Generating is just now I did, no? One by one after 4 months is there. So this is the way, right? What is going to be per month interest, per 4 month interest, and what is the simple interest formula? This is right. And apply there after 4 months each time. Do that. This is the total amount, interest, total amount plus interest, and apply again the rate.
Okay.
So in starting that your doubt is for in starting the symmetry, no?
Yes, sir.
Here, this one.
Yes, yes.
So here is the symmetry is the same. The thing is that, okay, so here is what is happening here. See, this is the graph of a power x when a belongs to 0 to 1. And I want to do symmetry along this line, y is equal to x. Okay. So symmetry now, in starting I said if it is y, this line is y is equal to x. So this, the main function is lying the positive side of y, then inverse will also will lie the positive side of x. This is one part. And now with the thinking of close and like it is as x is increasing, is becoming or coming to 0, close to, very close to, x is going to be asymptote. So similarly y is going to be asymptote, is here is x is going to be asymptote. So inverse y is going to be the asymptote for y axis is going to be the inverse for asymptote for the inverse, right? So but it is going to be the inverse. So how it could be, like this is one or this is one, how it could be? So this could be, this is, there are two possibilities, become the asymptote. So one is this one or this one. So which one is going to be? So this is not going to be, because the reason is as it is negative, or it is negative side is going to be that it is increasing. As it is negative side is there, it is increasing. And if it is as positive side, it is coming to 0. The same way can we think the exactly symmetry with respect to y is equal to x. Exactly symmetry with respect to this one.
Suppose y is equal to 1, then
Y is equal to 1.
Yes.
If it is y is equal to 1, then what is going to be the corresponding output where it is we are getting 1?
Yes.
At a power x. This is 1, then x should be what? 0, right? Then you will getting 1. Correct? So here it will be. So that's saying here, this one, somewhere it will intersect. So or either if you are not getting that, so the see about by this way.
Sir, log property 1, can you please explain?
So log property, the inverse I am saying, what is that? How the inverse is that log is actually created. The log is how the generative. So by this way you can think, no, this is the,
Just
if you
a
use
log value is just log 0 is a 1, log 1 point
log
point
1 is
something.
0.
Log
So by
0
this
is a
way
1,
you can
no?
think the symmetry.
Sir?
Huh?
Log 0 is a 1, no?
Log 0 is not 1. Log 1 is 0. Log 0 is not defined.
Oh,
Okay.
okay.
Okay. Thank you so much for joining. Now it's 9 also. I'm closing the session.
Sir,
Thank you, sir.
Yeah.
sir, I have a doubt in week 5 in one question, activity 5.9, last question.
8.9. What's your doubt here?
Sir, how to solve this question?
So fx is given, gx is given, hx is given, kx is the this one. So inverse is asking, no? So inverse, what is going to be the f inverse? No, inverse is that it says kx is inverse of f, f is inverse of h. So means you have to find the inverse, then which option is going to be true? That's the option, right? It says that k, this option says is k is inverse of f, or f is inverse of h, or g is inverse of k. This is the option meaning, right? No, you are not getting that option meaning itself. How you will find the inverse, is that clear? How you can get the inverse function, how we can find the inverse function? If not, then I will suggest you watch this tutorial, resource from instructor, or even I think in the last, how to find the inverse. Srikanth have tell is a very, I think he spent 30 minutes or 25 minutes to find the inverse, how one by one step he told you. And this option, what is the option says? Option says is k. See, this f inverse is k. So it says is k. This function is inverse of f. That's the you have to find, right? So that means you have to find the inverse of f. If it is exactly this k, then you will tell that okay, this option is going to be true. That's the meaning here. Is f function is inverse of h, means if you find the inverse of h here, inverse of h you will find it is exactly this function f. If it is yes, then this option is true.
Okay, sir.
Okay.
Yes.
Okay. Thank you so much.
Thanks, sir.
Thank you, sir. Good day. Thanks, everybody.
Thank you, sir.
Hello.
हाँ भाई मायना लगा है, बढ़िया।